They are the forms that need special type of further analysis for evaluations. So either you say that cannot be evaluated in the standard sense of evaluation, standard forms of evaluations, or you say that they need further analysis for evaluation. They mean the same thing. Okay. And I had talked of only two types of forms, namely 0 by 0 right now and infinity by infinity, in the sense that we have functions of this form, fx upon gx, and we have to evaluate limit x tending to a of this, and the situation is such that limit x tending to a fx is 0, and so is the limit x tending to a gx. Okay, either they are both 0, so it becomes a 0 by 0 form, or the other possibility could be that both the limits, limit x tending to a fx is infinity, and so is limit x tending to a gx. Okay, so then it takes the infinity by infinity form. Okay, now we, as we discussed in the last class, we cannot evaluate 0 by 0 in the normal sense. Okay, had it been a upon 0, had it been 0 upon a, things would have been different. But if it's 0 by 0, it becomes an indeterminate form. So as I mentioned, we had a French mathematician and he gave us a rule to evaluate such limits, and it's still called as the L'Hopital's rule to evaluate the limit. Okay. Now what he said was that if this limit has to exist, okay, then, and if it's a 0 by 0 form or infinity by infinity form, then limit x tending to a fx upon gx is equal to limit x tending to a f dash x upon g dash x. That means you are not differentiating this rational function. You are differentiating the numerator separately. You are differentiating the denominator separately. And the ratio of this, if you evaluate the limit again, then this limit will be equal to this limit, provided the function that you started with is either a 0 by 0 form or infinity by infinity form. Okay, so what happens is that once you evaluate this, this might turn out to be a finite limit. For example, the limit that we were discussing that day, we had started with limit x tending to 0 sine x by x. And we said, and we know that this limit is 1, right? But then we have evaluated, we have used different concepts to prove that the limit is 1. But actually, if you just look at this, limit x tending to 0, sine x is 0, and limit x tending to 0, x is also 0. So basically, this function is a 0 by 0 form. Okay, so we can evaluate, we can apply L'Hopital's rule here. So according to L'Hopital, so it's like your fx is sine x, and your, so that means your sine, fx is sine x, and your gx is x. Okay, so it's like, and your a is 0. So if you look at this formula, so limit x tending to a fx upon gx, where limit fx is 0 and limit gx is also 0 as x approaches a. Okay, so that's why it becomes a 0 by 0 form. So we can apply L'Hopital's rule here. So when you apply L'Hopital's rule, it has to be equal to limit x tending to 0. Now f dash x, now what is the derivative of sine x? Cos x upon g dash x. The derivative of x is 1.
1.
So it becomes this, limit x tending to 0 cos x upon 1. Now if you take the limit x tending to 0, cos 0 is how much? 1. So it becomes 1 upon 1, which gives you the limit as 1. So we can prove it this way also, that this limit is actually 1. Okay, and the same goes with infinity by infinity form also. Okay, now the point is, the question is that, can we terminate here? I mean, once we solve it, we evaluate the limit and we get the limit. Now, the question mark is, Will this happen every time? See, the possibility is that, this is a possibility. It can happen that limit x tending to a fx upon gx, this becomes a 0 by 0 form. We apply L'Hopital's rule and we say that this is equal to this, f dash x upon g dash x. Now, one possibility is like in this function, we get the answer, we get the limit. The other possibility is that, see, f dash x is the derivative of fx. So that means f dash x is also a function, some function, okay? Similarly, g dash x is also a function. So when we take the limits, the possibility is that this also ends up in a 0 by 0 form. हो सकता है, because है तो ये भी function. And when we take the limits, it may be possible that limit x tending to a f dash x भी 0 हो गया, and limit x tending to a g dash x भी 0 हो gaya. So that means it again becomes a 0 by 0 form. So that means we are stuck back to this situation only. Okay. So L'Hopital's rule says that no, you don't have to be stuck up here, in the sense that you can again, because it is a 0 by 0 form. So I forget about the fact that this was the first derivative. This is now my some different function, hx. This is my some different function, say lx. So it's a 0 by 0 form. That means I can apply the L'Hopital's rule again. So that means I can write this as f double dash x upon g double dash x. Okay, and then see whether the limit exists or not. The limit exists or not means whether the finite limit exists or not, whether the limit is 0, whether the limit is infinity. That all depends upon how this function ends up with. Okay, so that means we can apply L'Hopital's rule as many times as we want till we reach a situation where we can draw some conclusion about the limits. Some conclusion mean we can conclude the limit is finite, the limit is 0, or the limit is infinity, or the limit does not exist. Okay, so either way, we have to end up at some conclusion, but every time we apply L'Hopital's rule, we have to ensure that it is an indeterminate form. If it is not an indeterminate form, then applying L'Hopital's rule will give you a wrong result. It will not give you a correct result. So that's why every time when we apply L'Hopital's rule, we make sure that the limit is actually an indeterminate form. Like for example, yeah, it says let's take up this function, limit x tending to 0 let's look at this function, limit x tending to 0, 1 minus cos x upon sec x. So supposing we have to find this limit, okay? And what we do is we assume, we do not check whether it is an indeterminate form or not. We blindly apply L'Hopital's rule here, okay? So what do we get? By applying L'Hopital's rule, you will say that this is equal to limit x tending to 0. Now you will find the derivative of the numerator. Now the derivative of 1 minus cos x will be sin x, and the derivative of the denominator will be sec x tan x. Okay, now you simplify further and you get this to be limit. Simplify further, matlab you write tan x as sin x upon cos x. So this sin x gets cancelled and ultimately you get this as cos x upon sec x. Okay, because I can write this as limit x tending to 0 sin x upon sec x into sin x upon cos x. So this cos x goes up and the sin x gets cancelled and we get this. Now when I substitute x equal to 0, I get that this is 1 by 1. So the limit is 1. You conclude that the limit is 1. But actually, if you just look at the function here and you directly find limit by the substitution method. That means you substitute x equal to 0, you get this as, okay, I'm not writing, you know, how do you get? Okay, I'll explain it once more. 1 minus cos x, this is how we do by substitution method. Limit x tending to 0, sec x. Now x approaching 0 cos x. Cos 0 is 1. So this becomes 0 upon, and sec 0 is 1. So the answer should have been 0. Okay, so this is the actual answer. Because when I take the limits, this does not end up in a 0 by 0 form. Okay, so that means this function is not appropriate for L'Hopital's rule to be applicable here. Okay, so if I apply L'Hopital's rule, I'll end up with the wrong limit, whereas the correct answer is 0. So that means before you go on applying L'Hopital's rule, you have to first of all ensure that the form in which your function is ending up with is actually an indeterminate form. Otherwise, as in this case, we end up with a wrong answer. Okay. Similarly, we can have, we can have functions where we have to apply L'Hopital's rule more than once. We can have functions where we have to apply only once. But then the L'Hopital's rule can be applied only if our form is either 0 by 0 or infinity by infinity. Now, it's not that these are the only forms we'll end up with. I mean, another function that you are all familiar with is this. Limit x tending to 0, 1 plus 1 by x to the power x. याद है ये function?
Yes, ma'am. We take log.
I am not saying limit कैसे निकालते हो. मुझे ये बताओ कि ये लिमिट याद है या नहीं. ये तो लिमिट रटी हुई होनी चाहिए थी. Limit x tending to 0, 1 plus 1 by x to the power x. क्या होती है? Anybody?
1.
Who said 1? Mahima? Mahima ने बोला 1?
Yes, ma'am.
Anybody else? जिसको पता है ये लिमिट कितनी होती है?
Ma'am, infinity.
Anybody else? Akriti said infinity. और कोई?
Ma'am, 1.
एक मिनट, अब किसने बोला 1?
Ma'am,
शैली ने बोला 1. ओके.
Ma'am, E, exponential form, E.
E, शबिया ने बोला E. और कोई?
Ma'am, 1.
1. 1. ओके. अच्छा, अब जरा एक बार अपने आप से पूछो 1 कैसे?
Anything to the power 0. So
0 तो है ही नहीं. लिमिट x टेंडिंग टू इंफिनिटी लिखा है मैंने. Oh, sorry. I'm sorry. I'm talking of this. मैंने गलत लिखा. 1 to the power 0 is 1. Yes. फिर तो 1 ठीक बोल रहे थे सर. No. 1 x to the x tending to 0 में तो क्या होता है? This would have become infinity. 1 upon 0 would have become infinity. 1 plus infinity to the power 0. तो भी प्रॉब्लम था.
मैम
Now see this, limit x tending to infinity 1 plus 1 by x to the power x. मैंने गलत लिखा था, क्वेश्चन ही गलत लिखा था, सॉरी. अब बताओ.
मैम 1
1
1
कैसे?
मैम 1/infinity 0 हो जाएगा, उसके बाद 1 + 0 to the power infinity एंड 1 की पावर्स कितनी भी कर ले वो 1 ही रहेगा.
ऐसी बात है क्या? Again, there is a misconception in the sense 1 to the power a is 1 if a is any number, finite number, because only finite multiplication is defined. जब हम पावर एक्सपोनेंट्स की बात करते हैं, we say a to the power b, इसका मतलब क्या हुआ? a आपने मल्टीप्लाई करा कितनी टाइम? b times. So this is a finite multiplication which is defined. But when I say 1 to the power infinity, it is indeterminate, because infinite multiplications are not defined. Okay, so this is also an indeterminate form, but it is of the form 1 to the power infinity. Okay, not just this, we have other forms also, like 1 to the power infinity is an indeterminate form, 0 to the power 0 is also an indeterminate form, infinity to the power 0 is an indeterminate form, infinity minus infinity is an indeterminate form. Okay, so that means अब 1 to the power infinity का मतलब क्या हुआ? That means you have function of the form fx to the power gx. You are evaluating limit x tending to a, but is such that limit x tending to a fx is 1, but limit x tending to a gx is infinity. That is why it has ended up with an 1 to the power infinity form. So it is an indeterminate form, but we cannot apply L'Hopital's rule directly here, because L'Hopital's rule is applicable only to this, either 0 by 0 or infinity by infinity. Similarly, if you have this infinity minus infinity, like say supposing you have to evaluate limit x tending to 0, 1 upon x minus 1 upon sine x. Okay, so this becomes what? 1 upon x when x approaches 0, infinity. 1 upon sine x when x approaches 0, infinity. So it becomes infinity minus infinity form. So this becomes your fx and this becomes your gx. So it is like fx minus gx that you are evaluating, which is again in indeterminate form. But we cannot apply L'Hopital's rule because it is applicable only for 0 by 0 or infinity by infinity form. That means if we have any other indeterminate form like this, then it has to be first of all reduced to either by 0 by 0 or infinity by infinity, and then only we can apply L'Hopital's rule here. Okay, like this, as Shabia said, limit x tending to infinity 1 plus 1 by x to the power x is actually e. This is a standard limit, which normally is to be learned by heart, because this limit is e and we use it many times. Okay, but the point is how to prove that this limit is e. Once I know that this limit is e, then I must be able to prove also that this limit is e. Okay, so now how we go about? I'll talk of this type of function first. That means we'll talk of limit x tending to a fx to the power gx. If we have to evaluate this form where it is either 1 to the power infinity or infinity to the power 0, and whenever you have exponents as functions. Okay, so for such cases, what we do is we denote this function by y. Okay, so what we'll do is I'll say let y be equal to fx to the power gx. Now, what is the easiest way? Like supposing you have a function in the power. So what is the easiest way to remove this? क्या करते हैं? इस फंक्शन को अगर कुछ पावर में है उसको नीचे लेके आना है. So what is the easiest way?
log लेते हैं.
log.
We take log. So
Yes, ma'am.
same here. We'll take log on both the sides. ठीक है? इधर भी यही करेंगे हम. So please, I'm sorry for my handwriting today. So when you take log on both the sides, you get log y is equal to gx log fx. यही हो जाएगा ना? But we were to evaluate limit extending to a of y. Okay. So what we do is we take limits on both the sides now. So this becomes limit extending to a log y is equal to limit extending to a gx log fx. ये हो गया, ठीक है? Now, but हमें तो see what we have got on the left hand side is limit extending to a of log y. हमें निकालना क्या है? हमें निकालना है limit extending to a of y. But if I see limit and log, they are two continuous operations in the sense that, see, what does it mean? It means that you have y as a function. What are you doing? You are taking the logarithm of that first and then evaluating the limit. But since both of them are continuous operations, they can be interchanged in the sense that we can take the limit of y first and then take the logarithm of that. The answer is going to be the same. So we can interchange both these operations and we get that log of limit extending to a y will also be equal to this. Okay, gx log of fx, right? Now see, your function was, supposing we were evaluating 1 to the power infinity forms. That means your fx gx was 1 to the power infinity form. That means limit fx as x approaches a was 1 and limit gx as x approaches a was infinity. Okay, so if limit x approaching a gx was infinity, that means this term will be infinity. And since limit x approaching a fx was 1, that means log of 1 will be what? 0. So this becomes an infinity into 0 form. Still not 0 by 0 or infinity by infinity. That means I can still not apply my L'Hopital's rule here. Okay. But if I write this as limit extending to a log of fx upon 1 upon gx, can I not write like this? I have to have my gx in the numerator. ये gx मेरे को numerator में चाहिए ना? So in the denominator, I write it as 1 upon gx. Now, if I see as x approaches a, the numerator log, because fx was approaching in 0, now 1. As x approaches a, fx approaches 1. So this becomes 0. As x approaches a, gx approaches infinity. So 1 upon infinity makes it 0. So it gets reduced to a 0 by 0 form. Now you can differentiate, because now you can differentiate in the sense that now you can apply your L'Hopital's rule. Okay, so you differentiate the numerator separately, you differentiate the denominator separately, and apply your L'Hopital's rule. So what happens is that this limit, when you evaluate, will turn out to be some finite limit. Say supposing this limit turns out to be L.
Excuse me, ma'am.
हाँ जी, बोलो.
स्टेप है मैम, इसको बता दीजिए एक बार.
कौन सा?
मैम L लिमिट log limit extends to a y is equals to limit extends to a gx log fx.
अभी बताती हूँ बेटा. क्योंकि हमने लॉग लिया था ना बेटा, जो हमने जब दोनों तरफ लॉग लिया तो हमारे पास ये फंक्शन आया था ना.
Yes ma'am.
बट हमें तो अल्टीमेटली लिमिट निकालनी है, तो हम दोनों तरफ लिमिट लेंगे.
Okay ma'am.
ठीक है, हमने इधर भी लिमिट ली, हमने इधर भी लिमिट ली, ठीक है, बट लिमिट हमें किसकी निकालनी थी? y की, log y की नहीं। तो इसलिए हमने लिमिट को log के अंदर कर दिया, बिकॉज हम इन लिमिट और log को इंटरचेंज कर सकते हैं। ठीक है, मतलब कि कोई भी फंक्शन है, पहले उसका log लो, लिमिट लो, और whether you take the limit first and then take the log of that value, the answer is going to be the same. So that is why because both of these are continuous operations, taking limits and taking log. So we can interchange. Okay. Either we reduce it, it's not actually by hook or crook, but then we have to change the functions. We have to redefine the functions in such a manner that we end up with an indeterminate form. Because unless and until we have indeterminate form of the form 0 by 0 or infinity by infinity, we cannot apply L'Hopital's rule. So what happens is that this limit after certain evaluation will turn out to be some finite limit. कुछ आएगी, अभी करते हैं एक example, then it will be clear to you more. So it will be some finite limit, say L. But ये L किसकी limit आई? Log of limit y की. But हमें limit निकालनी किसकी थी? लिमिट y की। तो इसका मतलब ये log का ऑपरेशन हमारे पास एक एक्स्ट्रा ऑपरेशन है ना, which we don't want. So it's like what you have got, what you will conclude after this is that, or in a way what you are getting is that log of limit as x approaches a, y is L. So what will be limit x approaching a, y equal to? अब ये log हटाना है यहां से, तो क्या करोगे दोनों तरफ? लॉग का इनवर्स ऑपरेशन क्या होता है? दिस इज नेचुरल लॉग. व्हाट इज, इफ आई से नेचुरल लॉग ऑफ a is b, what does it mean? What is a equal to?
e to the power b.
e to the power
e
b.
to the power b.
e to the power b. Okay, so it's like that only. Log of limit x approaching a, y is L. So that means limit x approaching a, y will be what? E to the power L.
e to the power l. Yes, ma'am.
Okay, so whatever is your L, e to the power of that will be the limit of y. Okay, so like for example, अब जैसे वो वाला था हमारा एग्जाम्पल अभी जो हम कर रहे थे, जिसको मैंने शुरू किया था, लिमिट x tending to infinity 1 plus 1 by x to the power x. Supposing we have to evaluate this. Okay, this is what? 1 to the power infinity form. Okay, so what I do is I say that y be equal to 1 plus 1 by x to the power x. Now I have to remove this x from the power. So I'll take log on both the sides. I'm missing out these, steps which you have to write. I mean, I'm missing out my steps means I'm missing out how do you write. So for that, you can see the example and then write it the way it is written in the example. Okay. So this will be equal to x log 1 plus 1 upon x. यही आएगा ना? Now, we have to take the limits on both the sides. So it will be limit x tending to infinity log y will be equal to limit x tending to infinity x log of 1 plus 1 by x. Okay. Now see. It is limit x tending to infinity, x is what? Infinity. And this x tending to infinity, 1 by x becomes 0. So it becomes log 1, which I take as 0. So I conclude that this is actually a infinity into 0 form. Okay. But so I cannot apply L'Hopital's rule directly here. So what I do is I just have to get this x in the denominator. So I write this as limit x tending to infinity log of 1 plus 1 by x अपॉन 1/x. इसको लिख सकते हैं ना ऐसे.
मैम आपने में 1/∞ को 0 लिया है.
हाँ,
ओके मैम.
1/∞ तो 0 ही होगा ना बेटा. a/∞ is 0. Any constant upon infinity is 0. Any constant upon 0 is infinity.
मैम.
Okay. Now see, limit extending to infinity. Now the denominator is log 1, which is 0 upon 0. Now it is a 0/0 form. Okay. So now you have fx upon gx. And of course, not your original f, not your original x, gx, but then still it's some function upon some another function where both the functions approach 0 as x approaches infinity. So now it is a 0/0 form. So now we can apply L'Hopital's rule here. Okay. And when you apply L'Hopital's rule, that means you differentiate the numerator separately, you differentiate the denominator separately. So I can write this as limit x tending to infinity. Now, when you differentiate the numerator, it is what? Log of something. So what will be that? 1 upon 1 plus 1/x into the derivative of 1/x, which is minus 1/x square, upon, what is the derivative of 1/x? Minus 1/x square. Okay. Now this gets cancelled. And you are left with this as equal to only limit. I mean, you simplify this. Whatever you get, just simplify it. Okay. You are left with limit x tending to infinity 1 upon 1 plus 1/x. यही बचा ना, बाकी तो सब कैंसिल हो गया. And what is this limit equal to?
1.
1. Okay. Because as x approaches infinity, 1/x approaches 0. So basically, okay, I'll write it again. This is equal to 1 upon 1 plus 0, which makes it 1. Okay. But then, ये 1 क्या है? This is actually log of
Limiting value.
log of limit x tending to infinity of y is 1. Okay. So that means limit x tending to infinity, y will be what? E to the power 1, which is e. And what was y? Y was nothing but limit x tending to infinity, 1 plus 1/x to the power x. Okay. So that is why this limit is e. Now, to practice, just try this also. Then you will see the pattern. Okay. Try evaluating this. Limit x tending to infinity, 1 minus 1/x to the power x. Evaluate limit. They are not in the exercise probably, but I'm just asking you to evaluate these limits. Okay. 1 plus 1/2x to the power 2x. And also this limit x tending to 0, 1 plus x to the power 1/x. Yes. Evaluate this also. Okay. These three. I mean, I don't know whether they are your exercise problems or not, but then evaluate this. Okay. Then this is how we handle when you have functions in the power also. Let's see if you have something like let's see this function. Say, supposing you have to evaluate limit x tending to 0 cot x minus 1/x. Similar to what I had written, but I've taken an exercise problem now. Okay. limit x tending to 0 cot x minus 1 by x. Now, अब ये अब साथ साथ कर रहे हो ना? I hope you are writing along with me, or you are not
Ma'am.
just. I can write this as limit x tending to 0 cos x upon sin x minus 1 by x. ठीक है ना? Now, which form is it? Is it indeterminate? पहले तो ये बताओ. And if it is
Yes,
ma'am.
if it is indeterminate, then which form is it?
Infinity minus infinity.
Infinity minus infinity.
Infinite minus
See,
infinity. Yes.
when you put the limits, cos 0 is 1, sin 0 is 0. So it becomes 1 upon 0, right? Which makes it infinity. Minus 1 upon 0 again, which makes it infinity. So it is an infinity minus infinity form. Okay. Now, of course, again, we cannot directly apply the L'Hopital's rule because it has ended up in an infinity minus infinity form. So that means by some, I will not say manipulations, but yes, we have to work out some way that this function ultimately gets reduced to a 0 by 0 or an infinity by infinity form. Okay. Now, when you have a difference of two terms, what is the easiest way? What is the first thing that we do? Reciprocals में difference है, तो क्या करोगे सबसे पहले?
LCM.
LCM लेंगे, ठीक है ना? तो अब चाहे वो नंबर्स हैं, चाहे फंक्शंस हैं, तो हम इसका LCM ले लेते हैं. अब इसका LCM क्या हो जाएगा? x sin x.
X sin x.
ठीक है. और अब न्यूमरेटर में क्या रह जाएगा हमारे पास? दिस विल बी x cos
x minus 1
माइनस साइन x. ठीक है, हमारा फंक्शन इसमें रिड्यूस हो गया. ठीक है. अब इंस्टेड ऑफ डिफरेंस ऑफ टू फंक्शंस, इट इज जस्ट अ रैशनल फंक्शन नाउ. ठीक है.
It became
Now-
0 by 0.
Yes. Now, if you
Zero.
take the limits, what will be the first term? X cos x. Now, when x approaches 0, this x becomes 0, cos x becomes 1, right? So, this becomes what? 0 into 1. So, which is 0 minus 0 upon 0. So, this is a 0 by 0.
0 by 0.
Okay? So, now I am sure that this is now a 0 by 0 form. So, we can apply L'Hopital's rule directly here, right? So, when you apply L'Hopital's rule, you get this to be equal to limit x tending to 0. अब हमें न्यूमरेटर अलग से डिफरेंशिएट करना है, डिनोमिनेटर अलग से डिफरेंशिएट करना है. Now, the derivative of x cos x will be cos x minus x sin x. ठीक है ना? Because it's a product of two functions. Minus the derivative of sin x is what? Cos x upon. Now the denominator will be sin x
Sin x minus
minus x cos x. ठीक है. अब देखो, अब जो भी फंक्शन आया, पहले हमको इसको सिंप्लीफाई करना है, फिर लिमिट की बात करेंगे. हो सकता है यहीं पे ही आंसर आ जाए हमारे पास, राइट? नाउ सी, अब ये cos x कैंसिल हो गया एंड वी आर लेफ्ट विद लिमिट x टेंडिंग टू
साइन
0.
एक्स का डिफरेंशिएशन कोसेक्स होता है प्लस का.
Ma'am, plus x cos.
Plus x cos.
सॉरी, मैंने कहा था ना मैं गलती करती हूँ कई बार जानबूझ के. सो इट बिकम्स माइनस x sin x अपॉन sin x प्लस x cos x. इसमें रिड्यूस हो गया. ठीक है. अब इसमें लिमिट लगा के देखो तो क्या आ रहा है? When x approaches 0.
Minus infinity.
माइनस इंफिनिटी कहाँ से आ गया?
0 by 0.
Ma'am, 0 by
0.
What is the numerator when x approaches 0?
0 by 0. 0.
And the denominator when x approaches 0?
0.
0. 0 plus 0 is 0. So we get again a 0 by 0 form.
Yes, ma'am.
That means we can again apply the L'Hopital's rule. करना पड़ेगा क्योंकि अभी भी indeterminate है, right? So this becomes now when you differentiate the numerator, it will be minus sin x minus x cos x, ठीक है ना, upon cos x plus cos x minus x sin x, right? Which I can write as limit x tending to 0 minus sin x minus x cos x upon 2 cos x minus x sin x. Now take the limits. As x approaches 0. अब ध्यान से करना.
0.
0.
What is the numerator equal to? 0.
0.
0, 0. 0 into 1, 0. So it is 0. What is the denominator equal to?
2.
2.
Minus 0. So this becomes 0 by 2, which is 0. So we end up here.
0.
The limit ends up here. So that means the limit is actually 0.
0.
Is this clear? Okay.
Yes, ma'am.
Yes, ma'am.
But sometimes, it so happens that you have to think of some way or the other to write the things. Like, for example, you have to evaluate limit x tending to infinity x minus log of x cubed minus 1. Let's evaluate this. This is, by the way, this is question number 32 of your exercise. इससे पहले जो किया, I think that was question number 15. Yes. This is question number 32. Okay. Supposing we have to evaluate this. Okay. Now, which form is it? X tending to infinity. Either infinity, ठीक है, x तो infinity देगा. अब x infinity log infinity we take as infinity only, so it becomes again an infinity minus infinity form. ठीक है. Now the thing is that अब जैसे पहले वाले केस में था तो वो थे रैशनल फंक्शंस, रेसिप्रोकल्स थे, हमने एलसीएम लेके उसको रिड्यूस कर लिया. अब यहाँ क्या करें, एक में लॉग है, एक में लॉग है ही नहीं, राइट? तो यहाँ थोड़ा सा हम लॉग फंक्शंस की प्रॉपर्टीज यूज करते हैं. एंड आई ऑब्जर्व दैट this I can write, see, x. Can I not write x as log of e to the power x?
Yes, ma'am.
लिख सकते हैं कि नहीं?
मैम.
ठीक है ना, क्योंकि एक लॉग था तो मुझे दूसरी तरफ भी लॉग लाना था, because I can then use the properties of log, because I know that log a minus log b is equal to log of a upon b. ठीक है ना. तो अब क्योंकि माइनस के साथ एक लॉग था तो मेरे को इधर भी लॉग लाना था, सो आई कैन राइट इट एज लॉग ऑफ e to the power x minus log of x cube minus 1. So it's still infinity minus infinity form, and this I can write as limit x tending to infinity log of, now it's like log a minus log b, which I can write as ex. हाँ जी
मैम, log x क्यूब माइनस 1 को log x क्यूब अपॉन log 1 नहीं लिख सकते?
तो उसको हम क्यों इतना कॉम्प्लिकेट करें अभी, फिर भी ये x तो तंग करेगा ही करेगा. 2 टर्म्स की 3 टर्म्स हम क्यों बनाएं अभी से, वो भी जिसमें 2 में लॉग हो और 1 में ना हो.
ओके मैम.
ठीक है ना, सब में लॉग होता तो करते, बिल्कुल करते. ठीक है, क्योंकि उससे हमारे को कोई सोल्यूशन में हेल्प नहीं मिल रहा ना, अगर हम करेंगे भी तो. So I can write this as this now, limit x tending to infinity log of e to the power x upon x cube minus 1. Now अल्टीमेटली तो लिमिट निकालनी है. सो एंड जैसे मैंने पहले बोला था, लिमिट और लॉग इन दोनों को हम इंटरचेंज कर सकते हैं. सो आई कैन राइट इट एज लॉग ऑफ लिमिट x tending to infinity e to the power x upon x cube minus 1. अब हम इस टर्म को अलग से इवेल्युएट करेंगे. जो भी आएगा उसका लॉग लेना है, जो भी तो हमारी लिमिट आ जाएगी. ठीक है. नाउ इफ आई जस्ट लुक एट दिस टर्म x टेंडिंग टू इंफिनिटी, so e to the power infinity is infinity upon infinity minus 1 is infinity. So now this has reduced to an infinity by infinity form. And to infinity by infinity form, we can apply L'Hopital's rule. Because as I said, it has to end up either in a 0 by 0 form or infinity by infinity form. So in this, we can apply the L'Hopital's rule, and we observe that this will be equal to log of limit x tending to infinity. Now, ex upon 3x square. Fine. This is still an infinity by infinity form. So we apply again limit x tending to infinity ex upon 6x, which is again an infinity. So you can keep on applying till you reach a conclusion, as I said. Okay. Limit x tending to infinity e to the power x upon 6. Okay. Now I have a constant either in the numerator or in the denominator. So in this case, I have in the denominator. So when you take the limit x tending to infinity, it now becomes infinity upon 6. Okay, na? So which is nothing but infinity. So get the answer
Infinity.
as log infinity, which is infinity. That means the limit of this function is infinity. So we can apply L'Hopital's rule as many times as we want. But the only word of caution is that the function must be an indeterminate form. Okay, and not just an indeterminate form, it must be either 0 by 0 or infinity by infinity. That's why at every step you have to check whether it is infinity by infinity or 0 by 0, But then, there are certain interesting limits which look like as if L'Hopital's rule must be applied, but actually, they just give you the limit. Like, for example, yeah. Let's see this. Limit x tending to infinity, x to the power 3 by 2 sine 1 by x. Supposing I have to find this limit. क्या है ये? X tending to infinity. This is your
0.
Infinity into 0 form.
This is your question number 14. Okay, of the exercise. I think this exercise is which one? 4.5. Okay, I'm talking of 4.5 now. Anji, this looks like an infinity into 0 form. Okay, अब क्या होता है? Sometimes you just have to take care, in the sense that you just have to be sure that whether you actually need to apply the L'Hopital's rule or not. Okay, see, in this case, yes, it looks like it is an indeterminate form. It looks like an infinity into 0 form. So it looks like कि हाँ हमें लगा देना चाहिए. Okay. But if I just look at, see, there are certain standard results. That's why I said you have to keep in mind always. जैसे for example, उस दिन हमने prove करा limit x tending to 0, या आज ही prove करा limit x tending to 0 sin x by x is 1. Okay. Now, the moment I see this, can I not talk of limit extending to infinity sine 1 by x upon 1 by x? Are they similar? This function and this function.
Yes, ma'am.
क्यों similar है? Because I can always put 1 by x equal to t. ठीक है? The moment you put 1 by x equal to t, so as x approaches infinity, where does t go?
0.
0. So as x approaches infinity, my t is going to approach 0. And my function now becomes limit t tending to 0 sine t upon t, which I know is 1. आज ही prove किया है हमने. ठीक है? So that means even this is 1. So whether I have sine x by x as x approaching 0, or I have sine 1 by x upon 1 by x as x approaches infinity, they are 1. So the moment you get functions जहाँ पे sine 1 by x है और x approaching 0 है, we try to reduce this function so that we can use this result. Are you getting my point? Okay. See, I can always write this as इसको, if I just look at this function, और यहाँ पे x to the power 3 by 2 है, नहीं? So can I not write it as limit x to the power limit x approaching infinity sin 1 by x upon 1 by x? ये मुझे चाहिए क्योंकि ये लिमिट 1 होएगी. ठीक है, मेरे पास स्टैंडर्ड रिजल्ट है. इसका मतलब बेसिकली हमने क्या करा, इस x to the power 3 by 2 को स्प्लिट कर दिया. राइट? कैसे कि एक 1 by x हमारे पास यहाँ पे आ गया, तो इट्स लाइक आई हैव रिटन x to the power -1, एक ले लिया. सो व्हाट एम आई लेफ्ट विद? रूट x. इज इट राइट और रॉन्ग? गलती करी मैंने कहीं?
नो मैम.
नो मैम.
नो मैम.
ठीक है ना, कोई गलती नहीं करी. सी इट वॉज एन इनडिटर्मिनेट फॉर्म. अब देखो, ये लिमिट हो गई 1 एज एक्स अप्रोचेस इंफिनिटी. ठीक है, एंड एज एक्स अप्रोचेस इंफिनिटी रूट एक्स कहां जाएगा? इंफिनिटी. सो दैट मीन्स दिस बिकम्स 1 into infinity, which is infinity. ठीक है, अब इसका मतलब क्या हुआ? थी तो हमारे पास इनडिटर्मिनेट फॉर्म. कैसी? हमारे पास इंफिनिटी इंटू 0 फॉर्म. बट एक्चुअली हमको एल हॉपिटल्स रूल लगाने की जरूरत ही नहीं पड़ी डायरेक्टली, बिकॉज हमने इस फंक्शन को इस तरह से स्प्लिट कर दिया कि हमारे पास डायरेक्टली आंसर आ गया. हमको और कुछ करने की जरूरत ही नहीं पड़ी. सो यू मे कम अक्रॉस सच फंक्शंस आल्सो which look like they are indeterminate forms, but then with certain use of properties of your functions or of your limiting functions, you can actually evaluate the limits without calculating the limit. मुझे पता है तुम्हारी क्लास है, और मुझे पता है फ्राइडे को पीयूष सर की क्लास होती है मेरे बाद, और मैं पीयूष सर से बात कर चुकी हूँ कि मैं थोड़ा लेट छोड़ती हूँ फ्राइडेज को, एंड ही इज ओके विद इट. ओके,